All right, so coming back to APIs, yeah, southbound APIs, multiple options. Just to answer your question, OpenFlow, SNMP, because there's so many SNMP devices already existing, you can't ignore SNMP. Netconf, very popular. Uh, and remember, some of these APIs are auto-generated, and we will see, how they are generated using Yang models. And you have the legacy devices which use, the BGP protocol or the TCP protocol for MPLS networks. So there are your SDN controller is also capable of programming the legacy devices with such kind of protocols as well. And then you have the northbound APIs. Like I said earlier, the northbound APIs are the ones that make your complete network open. There are applications which use REST APIs to talk to northbound the modules within the SDN controller also talk to each other with help of APIs. Those could be REST APIs or Java APIs. And the interesting thing is that, because this completely opens up the ecosystem, your northbound application can also talk to your legacy systems like your OSS, BSS networks, and maybe your machine learning systems, and they can coordinate with those systems and exchange information to kind of further fine tune your network to make your network more programmable and manageable. So your network utilization can be improved, when your applications can also correlate with third-party systems. So a lot of these APIs, like these REST APIs, are auto-generated. So and that's based on the model-driven software abstraction layer. So you write Yang models, and we have a section on Yang models, so don't worry. Those Yang models are compiled to create the REST APIs, and then the applications that run within the SDN controller, they hook to the southbound APIs. Again, this is done seamlessly, so the application developer doesn't have to worry about the specifics of the protocol as such. Any questions on this? Okay, so this is about how you can use APIs to drive the policies of the network. So it's more like a conceptual thing. Basically, with SDN, you can make your network declarative. And just to draw an analogy, what declarative means is if you have written a SQL query, you do select star from a table and all the records come in. So the SQL query is declarative. So the person using that doesn't have to worry about where the data is actually stored in the file and how to retrieve that data. It's the job of the database engine to do that. It's something similar. So in SDN, you have policy level APIs where the applications can express their intent, and the SDN controller will do the job of programming and managing the network. So with this, I will now just have a short introduction to OpenFlow. OpenFlow is a protocol between the SDN controller and the network devices. It was basically it was invented by a company called Nisira sometime in 2008. So Nisira was the first successful SDN startup, which got acquired by VMware, and that solution is now part of the VMware NSX group, which is highly successful commercially now. So the founder of Nisira was Martin Casado, who's sort of very well known in the SDN world. He, along with his professor Nick McKeown, started Nisira. And the interesting story is that they started this company because the big vendors didn't believe in SDN. So they started this. They went on their own and created a successful company, Nisira, and that's where OpenFlow was actually created, the protocol between the controller and the network devices. So what does OpenFlow do? It basically the SDN controller programs flows into the network devices using the OpenFlow protocol. In the network devices, there are tables stored where the flow entries are kept. Flow entries are nothing but the fields on which you match for a packet. So, for example, if a packet comes in and you want to do a lookup on the destination address, IP destination address, then your flow entry will have a destination match field, and corresponding to that, there would be an action. So the action could be to forward the packet, to drop the packet, or send it to the SDN controller to tell what treatment it needs to be given. And in OpenFlow, there are certain counters for statistics purpose, that is used for KPIs. So in general, OpenFlow is a protocol that is used to program the network underneath. Okay, so that sort of basically covers the SDN architecture in principle. Any questions?
Are you going to talk about the flow of the packet as it comes into before we move to virtualization?
So there's another module on OpenFlow which we'll cover in detail. So all the different features and we would cover that. Yeah.
Sorry, mate. So the OpenFlow table on the NDF, that's similar to a forwarding table, is it? Like in sort of Junos.
Yeah,
So it's similar to Junos. It's got its own sort of version of the routing table.
Yes.
On the NDF, a bit like a forwarding table.
Yes.
So it's not relying on the controllers to do layer 2, layer 3 lookups every time. It's got its own local copy of the routing table.
Yeah, so there are different fields, and you do lookup on those fields based on what you have programmed. So if you have programmed to do a lookup on MAC addresses, then it would check the MAC address.
On the NDF.
When you say
so
NDF,
it's like a subset of the routing table on the NDF, like a forwarding table, if you like.
Yes.
Yeah. It's not doing a lookup
no,
every time.
No, not every time.
Yeah.
No, that would.
Sorry. Stupid question.
Yeah.
Hi, did you send the slide back?
You want to see? I haven't shared it with the slide, but I can do that.
All right.
Yeah. Okay. You guys want to take a break? Few minute break, or want to continue? So we have few more slides for this module. So want to finish this section and then take a break? Or want to take a break now? We'll finish this. All okay? All right, so this is a light section, so on virtualization, just a high-level overview, so it won't be heavy. Okay. So why we are covering virtualization in an SDN course is because SDN and virtualization are getting tied together, and I think even in Telstra context, you're using some virtualization pieces to program the networks. So that's the reason we are covering virtualization here briefly. So so from physical servers we have moved towards virtual machines and containers, and the reason is that you can leverage the hardware more. So on the same hardware you can leverage the CPU, memory, and network resources more efficiently, because now you can run several virtual machines and containers. Similarly, storage has got virtualized, so your machine doesn't have to know where your storage is, and it is independent of the actual storage hardware. So your storage could be located remotely, it could be on a storage server, but again virtualized, so that same storage, hardware storage, could be shared across different machines. And then now, network virtualization took some time to catch up with server and storage virtualization, and now it's become a necessity to create overlay networks, virtual networks, where your physical infrastructure is independent of the overlay networks. Like I pointed out earlier, you can have two virtual machines on different physical hosts across different physical networks, but yet on the same virtual network. Otherwise, or you can have two virtual machines on the same physical host, but they can be on separate virtual networks. So you have that flexibility of creating networks and having different machines on, though they are physically apart, they can be on the same network. So that's what network virtualization does. It makes your virtual infrastructure independent of the underlying physical infrastructure. So we talked about virtualization. What is network function virtualization? It's conventionally, telcos are deploying their services on proprietary hardware from vendors like the Cisco's, Ericsson's of the world. And that model is now shifting to deploying services on virtual machines and containers. So that is network function virtualization. So your firewall service, your SD-WAN service is now eventually moving towards this model where you make them run on VMs and containers. And then okay. So what is NFV? Basically, you have the physical servers, you have the physical network, and then you have the physical storage. But then on top of it, your entire virtual infrastructure is running. So you have virtual machines and containers, you have virtual networks, and then you have virtual storage. So your infrastructure is now independent of the underlying physical infrastructure. So if your service fails, it can be restarted on another physical host as a VM or a container. So that's where the industry is heading. Deploying services on virtual infrastructure. So this is the NFE reference architecture. So NFE is driven by standards body, which is the ETSI, European Telecommunication Standard Institute. So they have defined a reference architecture for NFE, and let's go through it. So you have the hardware resources for server, network, and storage. On top of it, you have the virtual infrastructure for compute, network, and storage. So these are your VMs, virtual storage, virtual overlay networks that sit here. And then you run your workloads in form of virtual network functions. So your firewall service, SD-WAN service, your mobile network service, or even your IP access service like the BNG border network gateways can run as virtual network functions on this infrastructure. And then to orchestrate these entities, the services and the virtual infrastructure, there is a MANO orchestrator, so management and network orchestration, which would actually automate deployment of, of your virtual infrastructure as well as the services. So this whole thing is actually defined by this body, ETSI. So they're working very hard towards it so the telcos can become more agile and and respond to customer needs much faster. And then you can this whole NFE platform can integrate with legacy elements like the legacy network management systems, OSS, BSS systems, analytics application, etc., etc. Any questions on this? So how does SDN fit with NFV? Um, so you have this. So this box that you see is nothing but the NFV reference architecture that we saw in the previous slide. So this whole thing is what this box does. So you have your physical resources, and then you have a hypervisor running on it, and then you have your virtual network functions, and this whole thing is orchestrated with an orchestrator. Now this orchestrator also connects with the SDN controller, which is what even Teresa is going to do. And with the help of that, you program the underlying physical and virtual network resources. That's how SDN integrates with NFV. This is another example in a bit more in detail. So you have the orchestrator, which is also known as virtual network function manager and network function virtualization orchestrator. So, so it manages both the services plus the virtual infrastructure, the spawning of VMs and containers. So there are two ways, your orchestrator can talk to the cloud manager, which is also known as the VIM, Virtual Infrastructure Manager, and like OpenStack is a good example of that. VMware vCloud is another example. And the orchestrator tells Vim to spawn the virtual machines with the help of Cloud Controller. So, your network services would be launched with the help of orchestrator. Uh, it would talk to the controller, and controller would launch these services. And your orchestrator can also talk directly to the SDN controller to program the underlying network devices. So this is the software-defined networking domain. You have the cloud domain here. So how NFE gets tied to SDN and virtual and network services is what you can see here. So one of the orchestrators is Cloudify. That's what we are going to talk about. Okay. Any questions so far? Am I going too fast, or should I reduce the pace or increase it? How is it like?
We're fine.
Fine. All right. Thank you. Okay. So Cloudify is a Mano orchestrator. It meets the NFV standards defined by the ETSI body. And the most important thing about Cloudify is that it provides model-driven orchestration of software applications, cloud infrastructure, and network infrastructure. What that means is it has the ability to create the cloud stack that you want without actually manually going and deploying the virtual machines and containers and installing software applications onto your platform. It is an open source product from Gigaspaces. And another important point is it uses a declarative and descriptive language. What that means is you define your infrastructure as code in a text file. You define what is the infrastructure that you want to create, what are the software applications you want to install, what is the network connectivity that you want, how you want to configure your network, your applications. All that is defined in a single file, which is known as Tosca blueprint file, which is that file is human readable, it's easy to understand, and Cloudify can parse that file and execute the actions to create that platform that you are looking for.
So, but Cloudify doesn't deploy the virtual machine or basically virtual network elements. After parsing that text file, the Tosca file, what goes ahead and actually deploys it?
The virtual network?
Yeah.
No, so Cloudify can talk to a virtual, it has a plugin to create the virtual networks as well. So let's say it will talk to Tungsten Fabric, and then that would create the virtual network. Or Cloudify has a plugin. OpenStack has a plugin, Neutron plugin. So Cloudify will tell OpenStack, and OpenStack will invoke Neutron APIs to create the virtual network.
And that's basically the definition of being model driven.
Model driven is everything is written in a human readable form. So your infrastructure is defined as a code. Okay. If you use Yang model,
So it's like Kubernetes when you have a declarative state and it pushes down.
yes. So declarative state means you just tell what you want, and it is a Cloudify's job to go and figure out all the details to execute the tasks.
OpenStack and SDN separate network, right? So the OpenStack is like make a network and the whatever compute or control coming together. But SDN is on the like implement on the bare metal switch.
Not necessarily. So your SDN controller can run on a virtual machine, okay, and your OpenStack can also talk to the SDN controller. So in fact, it does. There are so many open source projects like ONAP, OPNFV, which actually have integrated SDN controller with OpenStack. So if you want to program your virtual networks, configure your virtual networks, they can be done through OpenStack, which will talk to the SDN controller.
So Cisco, when I was leaving 2 years ago, they were moving towards OpenStack for their virtualization, basically. So the UCS platform, they were training up their people in OpenStack. So that's where they were moving with that, rather than say like a VMware or something like that.
OpenStack is a highly successful open source cloud solution. Okay. Any questions on Cloudify? So, what does Cloudify do? Like I said, you specify your application infrastructure as code. So it's a nice declarative syntax that you write, and you would tell what are the virtual machines you want, what you want to install in those virtual machines, what is the network connectivity that you want, what are the configuration parameters for the network. All that is specified in the blueprint file. You can also specify your policies. So if let's say there is an increased load on the platform, then your policy can trigger actions on Cloudify to create more instances of your virtual machine for load balancing purpose. So it can can do healing as well, which means if your infrastructure has, so your virtual machine has failed, it has gone down, then Cloudify would spawn another um, instance of that virtual machine on the same or another physical host. So with Cloudify, you specify your application infrastructure as code. You use it for configuration and deployment automation. So you don't have to go and manually do all those things. It also monitors your infrastructure and manages it. So it would continuously read KPIs from your different elements in the platform, the hardware, the virtual machines, the network services that are running. It would continuously pull data and monitor it. And if there is any failover, it would handle that. And if there is any extra load or the load has reduced, then it would take necessary actions to scale up and down the infrastructure. This is what Cloudify does, and of course, Cloudify has a limited scope when it comes to Telstra because they use Cloudify to program the OpenFlow network to create the different services like the E-line EP services, and we'll be talking about those later on.
So the software of the SDN controller itself is also pushed down by Cloudify, isn't it? Or you install it. Do you know what I mean? So Cloudify, you give definition of the network and what you want it to do, and it pushes it down and applies it. Deploys it, sorry. True?
Yeah, so good question. So Cloudify is a non-bound application for SDN controller. Think about it like that. And what we saw in the slides that the northbound application talk to the SDN controller with the help of APIs. And that's what Cloudify does. It invokes APIs on the SDN controller and the SDN controller will perform the necessary actions.
So any changes in the controller itself, you will have to go and use another tool or manually install it. Am I correct?
Yeah, you need those applications to understand those APIs and take those actions. So if you want to, let's say, deploy a OpenFlow service like E-line service, then there's an application running within the controller which exposes the API to Cloudify. Then Cloudify would call those APIs, but the detailed job of creating that service is taken care by the SDN controller.
Okay, but let's say you want to change the flows on a switch itself. Okay, do you again use Cloudify to do it, or you directly go and implement those changes in the controller itself?
So the controller's job, typically controller's job.
But he's saying, would you control the controller through Cloudify, or would you go directly to the controller?
That's basically the question.
Yeah, that's what he's asking.
So the flows are installed by the controller. Cloudify typically will not tell that install these flows on these network devices. That's not Cloudify is supposed to do. Again, it depends upon how you have developed the plugin, and we'll talk about that later. So it is an open thing, but whole thing about declarative syntax is you just tell what you want. If you have to specify what routes to install or what flows to install, then the purpose is lost. Then you are actually getting into the details of the network.
So just purely communication between Cloudify and the controller. Yeah, that's what it does.
Yes.
Only communication with the controller, nothing.
No, that's
Not changing the internal of the controller.
See, that's what the beauty of SDN is. Your northbound applications don't have to know anything about the underlying network. What are the devices, what protocols they support is completely unknown to Cloudify. And that's what a northbound application is supposed to be for. Alright, so any questions? We have finished the first module. I hope this is going at fine at a good space, or you want to be slow down, explain more, do let me know. You want to take a break? So it is 10:45. Should we get back at 11? Yeah. All right. Thank you.
Would you be able to send the slides? Would you be able to send the slides?
Yeah, you have a. I'm not connected to the internet. You have a backup drive. Just give it to me. I have a copy of the slides.
It's the big pop. Hey? Yeah. Have you got a stick? Young Vin.
Slowly.
How are you, buddy?
I was just gonna go around and see if they've got coffee and tea making things. Yeah. Otherwise, I'll just go out and sit in with them. Yeah. Do you want one or? No.
Still on the high.
You want to go on a walk? Yeah, let's go on a walk. I'll pick a coffee up.
Give you the tour.
Huh? Yeah, I want to go. Hey. You go on? You got coffees?
I was going to ask you to borrow the key and
Go on. Say hello to Yanni.
go see him. Sorry, Vin. Thanks. Sorry, son. Sorry,
Anthony, what time they start the class?
It's 9 o'clock tomorrow morning, mate. But it was 9:30 this morning. But apparently 9 o'clock tomorrow. Yeah, so it should be.
We had a lot of train delays in
Yeah,
Cranbrook back in the day. I like 2 buses on one train.
it's all over the place.
They're stopping all the stations.
Yeah, it's bad.
Tomorrow should be fine.
Yeah, tomorrow
The train.
the trains are resuming back.
I know. I understand.
Two buses stopping also.
Yeah, I know this one from you, so no worries. So all of these. So first, I think a lot of things was repeated, and for the time it came, so some concepts were repeated actually. So wouldn't have missed much.
Because we went to like underlying first all the way. So we don't discuss it.
No, we just talked about traditional networking model. What was not working model for modern requirements. So that's all. Yeah. I'm just representing. Yes.
How do they go open stack with this controller, like Cisco Juniper controller, and Cloudify is the API we're talking to. Where is Lumina's things?
Yes, Juniper is good.
I thought Cisco is only control, I think, Juniper is a controller. So Lumina is another ST controller.
That's open source control. That's what Telstra is using.
So open source means it's like, it's not a paid subscription or something.
Of course, otherwise they won't exist. So they have some value added offerings. We'll be covering those. What makes them special? Is this your? Is this yours? No.
Lumina is the when you store when you save the file, that's what you save. Yeah, I've seen it. I've seen what is. So the qualify is the code that you give frameworks and
I mean, we have a section on YAML. Don't worry. We'll go through that.
so Max is good. Putting Max in control is actually having our bounds down and whatever you experiment on, you configure the controller and then the Lumina strings the relationship instead and also input services.
This controller will not spin connection.
It will manage the service.
No, it will manage network.
Management of the often.
Yes, exactly.
And who will create the string negotiation? Those are all done by the
Open stack, cloud control. No, just the folder was very important.
How do you practice the lab?
So lab is 3D lab, so you need a laptop. You will have to use a laptop.
Today?
No, today. It's next week onwards. Yeah. So lab you will have.
It's in the city.
It should be here itself.
Oh, yeah.
I think lab should be here. I don't know unless they've changed actually.
And because of the GUI that you can log in.
Yeah, it's AWS accounts are not. Yeah, access to it.
Is Lumina mobile?
Lumina isn't selling. They have some but not anymore. So the sales director Kim, she hasn't come today, but she was for Melbourne.
What was like the main coins? What was it?
We decided people want to come early. 9:30 years. I was not there. I was told 9:30 is the time. We get done. Where are you from? Originally? Oh wow. Okay. It's very good. That's right. Okay. I'm from Pune actually. I forgot to mention. I'm from Pune. Yeah, I don't. No, no, no. I don't. I'm here for 3 weeks for this training program. Yeah, they have an office. I'm actually consultant for Lumina. No, 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 no. I'm actually part of the startup, which is consulting for Lumina. So we are actually doing this training. Yes. So it's a collab startup. Yeah. When you stay in London, it's oh. Oh, okay. This is not your.
No, I usually work in places. There's no all of them. That's for book.
Mhm. So part of the global operations team. And one person last year, George.
Oh, Jack.
Whatever the last
Oh, yeah.
Yeah.
Well, they're crying on the wall about it, as you know, I'm sure. Yes, cheers.
This place is training, not even cup to drink, no kitchen. You've got access, you know, from here. It's fine, but yeah, someone let us in, and but there's no cup even to drink water.
No, there is in a cupboard.
Is it?
Yeah, yeah. There is a cupboard inside. So you might have to take a cup.
Okay. Is it one time use cup?
No, no. Yeah, it's just that they are kept inside the cupboard, not in on the.
So when your
Mm.
business decides to save money, sure, it's like, well.
Mm.
What did you say that the cop that we can't find?
In the
kitchen.
Yeah.
I opened the cupboard and.
They didn't say anything. We just absorb it. And they said, what the heck is happening? We
Because
just
I
absorb
joined
it.
our people as you guys become here. So like I pretty much knew the most because I had to do stuff. It was ridiculous. We
Because
just-
they-
we had
they-
every-
They,
every
I
single
think they
order.
sent, well, Richard, did I think about it? It just happened about 1 or 2 days. It's not like I'm down for.
And you were taking his stuff off. Because they didn't know he said he was doing the job.
Oh. They're not really in the mode to teach you. That's the problem. Because they think that's not so much.
I mean, it just goes from.
Sounds great.
It is.
Hey, Machine, that's me.
Ah, that's you.
Yeah, you don't have my number.
Don't have to save it.
Hmm.
You're there now.
I called you just you were late.
Ian, Don.
Mama, do we have training next week for the lab?
For
For Lumina lab?
not I'm aware of.
We don't have, right? But I think maybe it was only for level 3. Ajay, how was today's train?
No, no.
2 buses. It was very tough.
It's a long journey.
The thing is, what happened was in Beaconsfield, they had all stopping to Dandenong. Dandenong again is changed to Express, stopping to Westall later. And play Westall, take a train. So, the stopping all station was the first bit tough. Like you see the whole suburb and you go like adventure.
Where do you get off?
I get on at Beaconsfield,
No, where do you get off here?
Melbourne Central. And then I came Melbourne Central, and then I put my GPS on, walking, and then I came.
Also, you didn't late because of the train industry, were you?
Yeah.
I thought you late because of the train
Yeah,
industry.
exactly. There was no train from Beaconsfield. If it's a train, I should be in the city by 1 hour. But because of train, I had 2 buses replacement. That's why I'm talking about bus from one end to another, from Beaconsfield to Berwick to Hallam, and then to Westall. It's a long way bus, and then that took 45 minutes. Another took 45 minutes.
Because there was an incident, in Flagstaff. It impacted us. I have to walk from the southern cross.
No, that got resolved, but all trains had especially Cranbourne Pakenham line had replacement, had bus replacement.
All the way from there to here, bus.
No, until Westall. Until Westall, they all bus. No, there's no train running.
So because of the incident, no.
I don't know what, but the public transport app showing that there's some delay, major delay, and they say that it take extra 60 minutes, so like 2.5 hours for.
Yeah.
You want to use that or?
Yeah, I think this point is not working.
Or the plug point. Alright. What we can do is. No, we can put it here.
Yeah, if that point is working, then maybe I can just do this.
Yeah, take that. And then there's another point here. There is another one.
No, I saw it on the train this morning. So, you carried Finch to Westall. So you fall.
Oh no, that's not working.
From Westall? No, from Spring to Westall. Did it work? Yeah. So I saw you on the same carriage, but you were.
Because it's not connected. I think they're not connected. These benches need hook on. But nevertheless.
Ridiculous. It took half an hour to Spring. Every week you get hit by. I'll see you guys next week.
Find one online or shop or the software issue.
Definitely Abdul as well. Abdul is working for sure. Abdul.
Yeah, I think it's not detecting.
sorry about that.
You have any? You have another one?
I just bought it yesterday.
So, the gentleman has copied actually.
Oh, is he?
So if you can transfer from
Yeah, no worries, mate. Sorry about that. Yeah. Strange format. Thanks for trying.
For how to find the top bar and the open for the top bar.
That's correct.
So it's not something between north and south, right? So like how to find just north bar. Right. North bar.
Oh man, that Flagstaff is where that guy took the gun, yes? You were there?
No, it was closed. I have to get off to Southern Cross. So it wasn't a gun,
So-
it was a guitar. He had a guitar in the back. It's actually, they thought it's a
Is it
gun.
all?
Yeah.
It's
That's what
getting nervous.
That's what the news saying.
oh man.
Are you sure there was no gun?
Yeah.
Getting nervous.
On the
There you go.
Gave him the sports USB stick that it doesn't recognise for some reason. So,
Oh, that's right.
so thanks, mate. Appreciate that. Sorry, I'm just
So you can do it both ways. So your orchestrate Cloudify can talk to the controller directly, which is what Lumina Extra is doing.
You want some?
Or your orchestrator talks to OpenStack. OpenStack will talk to the CPU. That is another device. So if you want to control bare metal, then escape controller. If you are
Is this yours?
running
Okay, so it's, yeah.
then you talk to
No, it's mine. I bought it.
Oh, is it? Okay, but yeah, no, it's,
overlays. The VM
it's
You can connect it. I thought you had extra on this already. Do you know the courses, you know?
did the Red Hat course.
So they saw this is different.
Yeah, it's sort of like this. So, doing his little bacon.
Yeah, it's the work of
Thanks for that, sir. Appreciate it, mate. Thank you, buddy.
Centrally, you can manage this.
Readable? Just put it on anything.
With Neutron,
Just
you
share
can
the guys name so
it's like to create these layouts. This will program
enough.
3.60.
All right,
Hey,
should we
Kingston.
get started?
Hey, Kingston.
Yeah, I hope so.
Okay, guys, let's start. Okay, so we are into the second module of training, and in this module we are going to cover OpenFlow in depth. So in the first module, I'll just recap what we did. We saw the limitations of the traditional networking, We saw some of the pre-SDN solutions to manage networks centrally. Then we explored the SDN architecture, in which the control plane and data plane is separated, how the network ecosystem is made open with the help of northbound and southbound APIs, and the net intelligence resides in the SDN controller. The northbound applications leverage the network to create to have an intent-driven programming. So the northbound applications don't have to know about the network details when you want to program and manage your network. And we had a brief introduction of OpenFlow. It's protocol to configure your underlying network, and we sort of touched upon network function virtualization and saw how Cloudify integrates with SDN controller to program the network. Okay, so in this module, we are going to go through OpenFlow, understand OpenFlow a bit more in depth. The idea is that you have a good understanding of SDN OpenFlow protocol, which will help you to debug your networks, troubleshoot your networks, and get a better idea of how the network is behaving. All right, so this is the OpenFlow architecture. You have an input packet coming in from one of the ports, and then there is packet forwarding logic, which would do a lookup on the different fields of the packet and decide from which port it has to be forwarded to. So the packet can go out on one or more ports if it is a multicast or broadcast case. If the device doesn't know how to read the packet, it would send it to the controller, which would then further tell the device how to send